Welcome children of class 10th. Now today children we are going to study chapter 3. We are in this chapter. We have studied part of it, and this is my sixth video on this chapter, and today we are going to study about the method of preparations of salts. Now children, salts are of two types: soluble salts and insoluble salts. The salts which are soluble in water, we say them as soluble salts, and the salts which do not dissolve in water, they are called as insoluble salts. And this solubility we are going to study in the next part of this chapter also. So children, in this table we see that the preparation of soluble salts is given. First method of preparation is by direct combination, that is by heating two elements together. If you see in this example children, a metal and a non-metal is getting reacted, is being heated together, and in the first case sodium and chlorine, they are heated together to form sodium chloride, a salt, and iron and chlorine are heated together to form ferric chloride. So this is direct combination. The next is children simple displacement. This is action of dilute acids on active metals, and children, you have studied this in the chapter hydrogen also. So we see that active metal like which are above hydrogen in the activity series, like zinc, iron, magnesium, they all react with dilute acids like sulfuric acids and hydrochloric acid to form salt. Like zinc plus H2SO4, it is giving you a salt, zinc sulfate, and hydrogen gas. In the same way, iron when reacts with hydrochloric acid give you ferrous chloride plus hydrogen. Then the next method is children by decomposition, that is decomposition of hydrogen carbonate by acids, decomposition of carbonates by acids, decomposition of sulfites by acid, decomposition of sulfides by acid. This reaction children you have studied in the part acids, where we studied that all the carbonates and bicarbonates reacts with dilute acids to give you salt, water, and carbon dioxide. So that's reaction, and the same reaction where children salt is prepared, we can use this method for the preparation of salt. Like all the carbonates and bicarbonates, bicarbonate like sodium hydrogen carbonate, when it reacts with hydrochloric acid, it gives you a salt NaCl, hydrogen and carbon dioxide is released. In the same way children, calcium bicarbonate, when it reacts with nitric acid, it gives you a salt calcium nitrate, water and carbon dioxide, and other carbonates also give you the same result. The next is children, all the carbonates, they react with the dilute acids to give you salt, water and carbon dioxide. So here copper carbonate reacts with hydrochloric acid to give you a salt, copper chloride plus water plus carbon dioxide, and magnesium carbonate reacts with the sulfuric acid dilute to give you magnesium sulfate, water and carbon dioxide. And children, carbon dioxide is common in all these reactions, salt, water and carbon dioxide is formed. And children, when we talk about decomposition of sulfites and bisulfites, we say that all the sulfites and bisulfites, they react with dilute acids to give you salt, water and sulfur dioxide gas. So if you see sodium sulfite, when reacts with the hydrochloric acid, it gives you sodium chloride plus water plus sulfur dioxide. In the same way, copper sulfite when reacts with nitric acid gives you copper nitrate plus water plus sulfur dioxide. In the same way, sodium bisulfite when reacts with hydrochloric acid, it gives you a salt NaCl plus water and plus SO2. Now children, the next is that all the sulfides, they also decompose by the acid, like potassium sulfite K2S. When it reacts with the dilute H2SO4 below 200 degrees, it gives you an acid potassium salt, potassium sulfate and hydrogen sulfide gas. This hydrogen sulfide gas has a peculiar rotten egg smell. Then zinc sulfide reacts with the sulfuric acid to give you zinc sulfate, and all the sulfides reacts with the dilute acids to give you salt and hydrogen sulfide. Now children, the next reaction is neutralization reaction. As we all know that in neutralization reaction, an acid reacts with a base to give you salt and water. And with soluble base, we say that children, nitric acid reacts with NaOH to give you sodium nitrate, a salt and water. Hydrochloric acid reacts with the sodium hydroxide to give you a salt NaCl plus water. HCl reacts with ammonium hydroxide to give you a salt, ammonium chloride and water. And in this way, children, a neutralization reaction is occurring. Then neutralization of an acid with an insoluble base. This is also neutralization, but the base is insoluble. Like for example, hydrochloric acid reacts with the magnesium oxide to give you magnesium chloride, a salt and water. Nitric acid reacts with lead oxide to give you lead nitrate and water. Lead nitrate is a salt. Then sulfuric acid reacts with copper hydroxide to give you copper sulfate, a salt and water. Nitric acid reacts with lead hydroxide to give you lead nitrate, a salt and water. These reactions, children, insoluble bases reacting with acids, and in the above case, the soluble bases are reacting. The soluble bases are also called alkalis. They are reacting with acids to give you salt and water. Then the last one is by the action of alkalis, that is NaOH and KOH, on certain metals like aluminium, zinc and lead. So children, as I told you before, that these salts or the hydroxides of these salts are amphoteric. So they react. For example, aluminium reacts with sodium hydroxide and water to give you a salt, sodium aluminate, NaAlO2. In the same way, children, zinc reacts with sodium hydroxide to give you sodium zincate, a salt. Aluminium oxide reacts with the sodium hydroxide to give you sodium aluminate and water. Aluminium hydroxide reacts with the sodium hydroxide NaOH to give you sodium aluminate plus water. Zinc oxide reacts with potassium hydroxide to give you potassium zincate. Zinc hydroxide reacts with potassium hydroxide to give you potassium zincate and water. So children, you see that soluble salts are obtained by the evaporation of water followed by crystallization. Some soluble salts like zincate and aluminates are found only in solution, and these salts cannot be obtained in the form of crystal. So children, when these salts are formed, what we do, children, we first boil them, we evaporate all the water, and then it crystallizes out to get solid crystals. So this is the way to collect these salts in the form of crystals. Now children, we come to the preparation of some insoluble salts. So insoluble salts, as I told you, are those salts which are not soluble in water. First is by direct combination. If you say lead and sulfur, if you combine them together and they form lead sulfite, an insoluble salt. In the same way, iron plus sulfur give you iron sulfide or ferrous sulfide, and this is again an insoluble salt. Then next is by the combination of an acidic oxide with a basic oxide. Now SO2 is an acidic oxide and CaO is a basic oxide. It reacts to give you calcium sulfite. In the same way, carbon dioxide reacts with calcium oxide to give you calcium carbonate. Then the third one is, children, by the precipitation reaction or by double decomposition reaction. Like for example, barium chloride reacts with sulfuric acid to give you an insoluble salt, barium sulfate. It is white PPT plus HCl. Silver nitrate reacts with hydrochloric acid to give you a white PPT salt, silver chloride. PPT means insoluble. It is a solid formed in the reaction. And nitric acid. Lead nitrate reacts with the sodium carbonate to give you lead carbonate plus sodium nitrate. Then sodium sulfate reacts with barium chloride to give you barium sulfate and sodium chloride. So all these are salts which are precipitated out, and the arrow downward is showing an insoluble salt. Then copper sulfate reacts with hydrogen sulfide to give you copper sulfide plus sulfuric acid. Lead nitrate reacts with hydrochloric acid to give you lead chloride plus water. Now children, this lead chloride is a salt which is insoluble in cold water, but it is soluble in hot water. So an insoluble salt can also be obtained from another insoluble salt by double decomposition. Children, if you want to prepare an insoluble salt from an insoluble salt, then you have to follow a double decomposition method. That insoluble salt is first to be converted into soluble salt, which can then be used to prepare the desired salt. For example, children, insoluble lead sulfate is prepared from insoluble lead carbonate or lead insoluble lead oxide by first converting either of them into soluble lead nitrate with the help of nitric acid or with the help of any nitrate. Children, lead oxide is an insoluble salt. First we dissolve it in nitric acid to form lead nitrate, or lead carbonate is an insoluble salt which we react with nitric acid to form lead nitrate. Now children, this lead nitrate is soluble and the resulting solution is then treated with sulfuric acid or sodium sulfate solution, and a white PPT of lead sulfate which is insoluble is formed. So lead nitrate when reacts with any sulfate, hydrogen sulfate or by sodium sulfate, it reacts and give you to an insoluble salt, that is lead sulfate and nitric acid. So children, one very important thing, if you want to prepare an insoluble salt from an insoluble salt, then first the insoluble reactant is first converted into the soluble product, and that soluble product basically is a nitrate, and then that nitrate is reacted further. So a chemical change in which two compounds in solution reacts to form two other compounds by mutual exchange of radical. A solid precipitate is formed as a result of reaction. So children, here we say that adding dilute sulfuric acid to PbCO3 in order to prepare lead sulfate is an impractical method, because an insoluble crust of lead sulfate is formed on lead carbonate which prevents further reaction. So children, when we are preparing lead sulfate from lead carbonate, this reaction stops because a insoluble crust or insoluble layer of lead sulfate sticks to the lead carbonate and it further stops the reaction. And children, very important thing which we am saying, that lead chloride is prepared from insoluble lead oxide or lead carbonate by the same method. So silver chloride and barium sulfate. Silver chloride is usually prepared by the reaction of aqueous silver nitrate with dilute hydrochloric acid, and a precipitate of silver chloride is obtained. So children, when AgNO3 plus HCl gives you AgCl, which is white PPT, an insoluble salt and nitric acid, children, this reaction we use for the identification of chloride ion also. And barium sulfate is prepared by the reaction of aqueous barium chloride with dilute sulfuric acid. So BaCl2 plus H2SO4 gives you barium sulfate, white PPT, and hydrochloric acid. This reaction we use in the analysis of sulfate ion. Now children, we come to the laboratory preparations of some salts, and we say that first is children, ferric chloride. Method of preparation is by synthesis or by direct combination. So the procedure is with certain apparatus like this. Powdered iron is taken in the combustible tube. Combustible tube is the center tube where heat is written, and dry chlorine gas obtained by passing the gas through concentrated sulfuric acid. Children, when we pass any gas through direct concentrated sulfuric acid dry up that gas, or if any moisture is present in that gas, that is absorbed by sulfuric acid, is passed through the combustible tube. The air inside the apparatus is expelled and the iron turns red hot since the reaction is exothermic. Now external heating is suspended and ferric chloride is formed, which volatilizes and condenses in the receiver as brown scales. So ferric chloride is obtained. So children, the reaction is that Fe plus Cl2 is giving you ferric chloride, FeCl2. Now children, in this diagram, if you see, there is fused calcium chloride written. Now this has been placed as a drying agent over here, because ferric chloride is such a salt that it absorbs moisture from the atmosphere and it even dissolves. So to remove any moisture in this flask, we have connected it with fused calcium chloride to make this dry. So children, this is the method. Now the reaction of this is given 2Fe plus Cl2, 3Cl2 is giving you ferric chloride, and ferric chloride is highly deliquescent. Deliquescent means that these are those substances which absorb moisture from the atmosphere and they dissolve in it. So we are going to study it in detail in the next part of this chapter. So it is kept dry with the help of fused calcium chloride as drying agent. Anhydrous ferric chloride cannot be prepared by simple heating the hydrated ferric chloride, that is FeCl3.6H2O, because on heating, ferric chloride hydrated produce ferric oxide hydrated plus HCl. So children, by this experiment, ferric chloride cannot be prepared as this reaction occurs, and anhydrous ferric chloride is used as a catalyst in many reactions. The next is children zinc sulfate and iron sulfate or ferrous sulfate. Method of preparation is displacement by the action of dilute hydrochloric acid or sulfuric acid on active metal like zinc. For example, zinc sulfate, children, we know that zinc plus H2SO4 gives you zinc sulfate plus hydrogen, and this salt can be prepared, children, when we have what we do, we take the dilute sulfuric acid 1 volume acid and 5 volumes water in a beaker and heat it on a wire gauze, and add granulated zinc piece a little at a time with constant stirring. Effervescence takes place because liberation of hydrogen is taking place. So you see bubbles of gases coming out, which is hydrogen, and add zinc till the metal settles at the base of the beaker. We keep on adding zinc pieces until the reaction stops. When effervescence stop, indicates that all the acids has been used up and the excess of zinc is filtered off. Collect the solution in china dish, evaporate the solution to get crystals, filter, wash them with the water and then dry between the folds of filter paper, and you get, children, hydrated zinc sulfate, that is ZnSO4.7H2O. So these crystals are white in color, so they are also called as white vitriol. So children, the diagram for this is given, and first of all we do this reaction, then we dry it in this crucible, and we get we filter it and we dry it, and we get crystals of zinc sulfate hydrated. The white needle shaped crystals are hydrated zinc sulfate, commonly known as white vitriol. Now children, a ferrous sulfate or green vitriol, it is also prepared by the displacement. So iron sulfate is prepared by displacement, action of acid on active metal. For example, iron plus H2SO4 gives you ferrous sulfate plus hydrogen, and ferrous sulfate reacts with 7 water molecules to give you hydrated ferrous sulfate. Now this is green in color, so it is called green vitriol. Filter the hot solution and allow the filtrate to evaporate at room temperature. Pale green crystals of hydrated ferrous sulfate are formed. Now children, we come to the third preparation, that is lead chloride and calcium carbonate. Method of preparation is double decomposition, precipitation reactions. An insoluble salt can be prepared by mixing the solution of two appropriate salts, each containing one of its ion. The mixing results in the formation of an insoluble solid precipitate which can be filtered, washed and dried. Say for example, children, we want to prepare lead chloride. It is prepared by adding either dilute hydrochloric acid or sodium chloride solution to a solution of lead nitrate. So you can see the reaction given here, children. PbNO3 all thrice plus HCl or plus NaCl gives you lead chloride, which is insoluble, and nitric acid or sodium nitrate is formed. So children, if you see this insoluble salt which is prepared as lead sulfate, it is filtered, we filter it, and then the solution of lead nitrate and sodium chloride is then filtered, and the heavy white precipitate of lead chloride accumulates as a residue on the filter paper. It is then washed repeatedly with the cold water. The precipitate is taken in china dish with some water and is heated till the precipitate of lead chloride dissolves. The solution is then cooled. Pure needle shaped crystals of lead chlorides are obtained, and lead chloride dissolves in hot water. So chlorides of lead, silver and mercurous and sulfates of barium, lead and calcium are also prepared by this method. Now children, we see the preparation of calcium carbonate. It is prepared by adding sodium carbonate solution to a hot solution of calcium chloride in a beaker till the former is in excess. So children, we see that calcium chloride plus sodium carbonate reacts to give you calcium carbonate as an insoluble salt and sodium chloride which is soluble. So the white precipitate formed by the interchange of radical is filtered. They are washed repeatedly with cold water and collected. The washed precipitate is dried to obtain an amorphous powder, that is calcium carbonate. And the carbonates of all metals except sodium, potassium and ammonium are prepared by the above method. And sodium, potassium and ammonium cannot be prepared because they are soluble compounds. Now children, we come to the preparation of an acid, salt, sodium bicarbonate. So it is prepared by passing carbon dioxide gas into cold solution of sodium carbonate. The reaction is sodium carbonate plus carbon dioxide plus water, and the reactant is the product is sodium bicarbonate. So procedure is children, we dissolve nearly 5 grams of anhydrous sodium carbonate in about 25 centimeter cube of distilled water in a flask. Cool the solution and keeping the flask in the freezing mixture. Pass carbon dioxide gas in the solution. Crystals of sodium bicarbonate will be precipitated out after some time. Filter the crystal, dry it in folds of filter paper, and we prepare it. So children, you can see the diagram given over here, and this reaction takes place and you get crystals of sodium bicarbonate. Note, sodium hydrogen carbonate is used in health salt. So health salts are the mixture of dry citric acid or tartaric acid or sodium hydrogen carbonate. On adding water, acid reacts with sodium bicarbonate to liberate carbon dioxide, which forms an effervescence ring and releases gas pressure in the stomach. So children, this is now children, the next is the neutralization reaction. And as we all know that neutralization is a process by which hydrogen ion of an acid reacts completely with the hydroxyl ion of a base to give you salt and water. For example, a base NaOH reacts with an acid HCl to give you NaCl plus water, and the ionic reaction is given children. The OH negative ion and the of an base and H ion of an acid reacts to form water, and the sodium ion and the chloride ion reacts together to form sodium chloride. So Na plus or sodium ion and chloride ion are present in the reactants as well as in the principal product. Thus, by cancelling out the ions present in the reactant as well as in the product, we get the following reaction, and this ionic reaction of even potassium sulfate is given. Now children, there is one term coming up which is heat of neutralization. Now it is the amount of heat liberated when 1 gram equivalent of an acid or a base is completely neutralized. So when this neutralization reaction takes place, the amount of heat liberated when 1 gram of an acid or 1 gram of a base reacts completely or to neutralize itself is called as heat of neutralization. Now children, we come to the preparation of copper sulfate or blue vitriol. Copper sulfate children is CuSO4, but it comes in a crystal form as hydrated copper sulfate, which is CuSO4.5H2O. If it is copper sulfate, it is amorphous white powder, but if it is hydrated copper sulfate CuSO4.5H2O, it is blue crystals, and we call it as blue vitriol. The method of preparation is children neutralization of insoluble base. By the action of dilute sulfuric acid on an insoluble base, copper hydroxide, copper oxide or copper carbonate, we get this reaction. Copper hydroxide reacts with the sulfuric acid to give you copper sulfate plus water. Copper oxide reacts with sulfuric acid to give you copper sulfate plus water. Copper carbonate reacts with sulfuric acid to give you copper sulfate plus water plus carbon dioxide, and this copper sulfate reacts with water molecule to give you crystals of copper sulfate, which is blue. So take dilute sulfuric acid in a beaker, heat it on a wire gauze, add copper hydroxide or black cupric oxide or copper carbonate in small quantities at a time, and keep on stirring. The solution will no more till the solution no more of it dissolves and the excess compound settles to the base. Filter it hot and collect the filtrate in china dish. Evaporate the filtrate by heating to the point of crystallization and then allow it to cool. Collect the bright blue crystals of copper sulfate, pentahydrate, blue vitriol and dry the crystal. Note the other salts which are prepared by the same method are zinc sulfate, lead nitrate, calcium chloride, calcium nitrate, and magnesium sulfate. So children, these can also be prepared. Now children, we come to the preparation of sodium sulfate crystals, that is Na2SO4.10H2O. It is sodium sulfate decahydrate. So neutralization of an alkali, that is a caustic soda with dilute sulfuric acid. Say for example NaOH plus H2SO4 gives you sodium sulfate plus water. Now children, there is a problem in it that the reactants and the products, they both are soluble in water. So when the reaction completes, we do not come to know whether the reaction is complete or not. If when we are preparing the salts of sodium, potassium or ammonium, so this method is useful for preparing the soluble salts of only sodium, potassium and ammonium. Since the reactants as well as the products are soluble, a titration is conducted to determine the completion of the neutralization reaction. So children, a new word titration has come. Titration, children, is an experiment which we do to find out how much of an acid or a base is required to for complete neutralization. So this we find out by an experiment, and this experiment is called titration, children. So here are some procedure how we can continue with the titration. Then step 1 is, children, we take 25 centimeter cube of sodium hydroxide, or it can be any calculated amount, in a measured flask and transfer it to a conical flask. A drop of indicator like phenolphthalein is added. The solution turns pink. As we all know, children, that sodium hydroxide or any base in phenolphthalein turns pink. Then a burette is filled with dilute sulfuric acid, and the reading on the burette is noted, that is 0 cc. The acid is turned and dropped into the conical flask or alkali till the last drop of the acid turns the solution colorless. This is known as the end point. Note the burette reading at the end point. The difference between the two reading is the volume of acid required. Now children, this is the diagram given for titration. Here in the conical flask we have stored 25 cc of sodium hydroxide, and we have put few drops of phenolphthalein. So this sodium hydroxide turns pink, and in this tube, which is called the burette, we have added dilute sulfuric acid. Now children, we open the tap of this burette drop by drop, and we keep stirring it, or we keep dissolving that acid in water, and drop by drop a point comes when this pink color changes to colorless. So children, at that point we mark the reading on the burette, and we come to know how much volume of acid is required. So children, for 25 cc of sodium hydroxide, how much acid is required, we come to know on this scale, and then we can do that reaction with that. Suppose 25 cc of sodium hydroxide requires 20 cc of sulfuric acid. So that is the scale. So next time whenever we are doing this reaction, we add the base or the alkali and the acid according to that calculated amount. So the reaction comes to finish and we get only the product. So the reactants are not left within the product. So the acid and the alkali in the same ratio found above are now mixed in the evaporating basin. The resulting solution contains sodium sulfate and water, and on evaporating this solution, crystals of hydrated sodium sulfates are obtained. In place of children sodium hydroxide, sodium carbonate can be used in this reaction. However, in place of then phenolphthalein, we have to use methyl orange and indicator. Since sodium hydroxide and sulfuric acid are both soluble, and excess of either of them cannot be removed by filtration, therefore it is necessary to find out on small scale the ratio of the solution of the two reactants required for complete neutralization before preparation. Now children, in order to prepare say acidic salt of sodium bisulfate, we can add the same volume of sulfuric acid again to the product formed in preparing the normal salt, that is sodium salt. Crystals of sodium hydroxide sulfate, sodium hydrogen sulfate are obtained from the resulting solution. For a given amount of alkali, the addition of twice the normal amount of acid will result in the formation of acid salt. So for example, if we add twice the amount of twice the amount of children acid, then the reaction will be sodium bisulfate plus water. So this is regarding the preparation of salt. So children, we have completed this part of this chapter and we have to still continue with this chapter. As I told you, this is a long chapter. I hope you have followed this chapter till here.